This presentation concerns the use of formal charge to select a preferred Lewis structure of a molecule that contains a central atom that can be hypervalent. While the second row elements can only accept an octet of valence electrons, elements in the third row and higher can become hypervalent, thus exceeding an octet of valence electrons assigned to those atoms. This is the origin of hypervalent Lewis structures. Simpler examples include phosphorus pentafluoride, where phosphorus has 5 bonding pairs assigned to it, sulfur tetrafluoride with 4 bonding pairs and 1 lone pair, and chlorine trifluoride with 3 bonding pairs and 2 lone pairs. In these 3 molecules, each atom has a formal charge of 0. If the additional electron pairs had not been assigned to the central atom in each case, other more complex types of structures would have been needed, and those structures would not meet the requirements of formal charge. Such structures will be considered in chemistry courses at a higher level than general chemistry. In some structures, such as that of the perchlorate anion, an octet conforming structure can be obtained easily following the steps that have been outlined previously. When calculating the formal charge, it is found that all of the atoms on the octet conforming perchlorate anion have non-zero values. Since the chlorine central atom can become hypervalent, the formal charges can be reduced by forming multiple bonds between the terminal oxygen atoms and the central atom. Here is the octet conforming structure and 4 possible hypervalent structures with multiple bonds symmetrically formed one at a time. In all of the structures, the formal charges add up to equal the total charge on the molecule. When the formal charges are calculated for the atoms in each structure, preferred structure is that with the most atoms closest to 0 formal charge. 2 of these structures have 4 atoms with 0 formal charge and 1 atom with a -1 charge. The choice between these 2 structures is made by recalling that a negative formal charge should be assigned to the most electronegative atom in the structure. From the determination of the molecule's central atom, recall that oxygen has an electronegativity of 3.44. and chlorine has an electronegativity of 3.16. So the structure with 3 double bonds to the chlorine is the preferred structure based on formal charge, making chlorine hypervalent with 14 bonding electrons. The next presentation in this series will consider the construction of Lewis structures containing more than 2 atom types.